So let's look at what's called mapping notation. So we have some function here, and the transformations or the translation of the function are defined by certain variables within the equation, right? And these variables, we just have to be able to recognize them. There's a variable that we use the letter A to represent, one that we use the letter K, we use the letter C, and the letter D to represent them. And once we're able to pick those variables out of an equation, so here's the equation we're going to use, so we're going to get into that in a sec, we can apply them to these two small equations. And these two small equations will help us take coordinates we already know from the parent function. This is our parent function because it's a root function that we're working with. And just find out where the new coordinates would translate to. Okay? And really what this means is the new x value is equal to the old x value, so the x value of the parent function, wherever that coordinate is. And this is how we apply the k and the c to that one point. So the new coordinate, okay, so I'll kind of show you the old coordinate we kind of define as x, the old x, and the old y. And then once we put it through mapping notation, it comes out as the new x and the, whoops, that's not what I was looking for, and the new y.
Yeah.
Okay, so y subscript n. I know I'm using lots of funny little letters, but it's just to help us organize stuff. So when we look through this, what number represents our a value?
-2.
Perfect. So we have -2, there's our a. How about k?
-1.
Yeah, that's right. It's kind of an invisible one there. How about our c value?
+2.
Great. And we're going to talk about this value because that one's a bit tricky there. And a d value?
5.
5. Great. So we have our d value. Great. So our two equations read x n is equal to, actually I'm going to do y first because it's a little easier. The new y value is equal to -2 times whatever our old y value was, plus the number 5. Okay, so we're going to apply that equation to each coordinate.
Oh, that's a formula.
That's a little formula for us. Yeah, we've plugged that in, so now we have a new formula. Our new x value is going to be our old x value divided by whatever that was. So in this case, it's -1, which is really easy. If this is like a fractional number, then this gets a little convoluted, but it ends up just being multiplication. I'll quickly show you that because it is an important idea to know. Say k had been the number 1/2. Well, when I put it in there, our x old would be divided by 1/2. So when you divide fractions, you x old divided by 1/2, and then you
Times 2.
exactly. So it just becomes 2x old. That's the easiest way to think of it. Okay, so this is just a note. Put this as a note here. Just keep that in mind since we didn't have a fraction. And then our c value. So the c here, it says to take an addition of it. Okay, the c value is actually a negative here. Okay, so the true number is a -2, so we put in -2 here. That's what's really important. If we end up taking what we see in the equation, this won't quite work, the mapping notation. So make sure you pull out the correct value when you do it. Okay, so now we have our mapping notation for this. What's nice about this is we have a root function, and I can pull out the important root values pretty simply. So I'm going to make a little table. Okay, when x is 0, y is 0. When x is 1, y is 1. When x is 4, y is 2. Because all it is finding the square root of the x values, which means 9 is 3, 16 is 4. And I don't think we really need more than that.
Is that like the standard?
Yeah, so from the parent function, I'll show you on the graph, think of that as like our standard values. I'll put these coordinates in. 0, 0. That's an obvious one,
Yeah.
right? It lands right there. And 1, 1. That lands on it too. So I've worked with the function so many times that I know the key coordinates in it. We could use other values like these numbers here, but they're really ugly and not easy to work with. So it's easier if I just use like the whole numbers when I go through it. 4, 2 is another one that falls on here. And 9, 3. And then I hope you take my word for it that the next one falls on it too. Okay? So now that we've done that, each of these is a coordinate, like we said, right? 1, 2, 3, 4. Sorry, 4. I got 5 coordinates. I'm not going to go through all of them, but I'm just going to show you the process of it. So this is considered the x old and the y old. Okay, so if you remember our little equation where we write it over here, xn is equal to, when I divide by -1, it's the same as multiplying.
Yeah.
So I'm going to say x old minus 2. That's our one equation. And the new y is -2y old plus 5. Great. So this is just literally plugging values in and getting new coordinates. Let me move this over so I can make a new chart here. So my chart that's going to correspond to this, I should use straight lines, is going to use our new x value and our new y value. So these are where the points have moved to after being translated. So we plug in 0 here. So our x new is equal to negative 0 minus 2. Our x new is negative 2. So this coordinate moves to negative 2. And that same y value, we plug that in. X new is equal to negative 2 times 0 plus 5. It's just 5. So that coordinate has now moved to negative 2, 5. Okay? So I've put it through that. So I've moved one of them, so we know that's going to be on it. And then we run the same equation for the next and the next. Let's try the next one. Our new x new, it's negative 1 minus 2. So it's going to be negative 3. Are you okay with that?
Yeah.
Did I do that fast? Okay. Negative 3. And our new y new is negative 2 times 1 plus 5. So that's negative 2 plus 5, which is positive 3. Okay?
So this equation works every time.
Yeah, it works. As long as you set it up properly, it'll work every time. And now, it won't give you every coordinate,
Yeah.
but you can kind of connect the dots when it comes to the next part. So we'll do 3 of them just to prove that they fall. The next one is 4, 2, which is good. So x new is equal to negative 4 minus 2. So we get negative 6 here. Assuming I'm doing the computations right in my head. Negative 2 times 2 plus 5. That's going to be negative 4 plus 5, which is just 1. So negative 6, 1. Okay, so I've done 3 of them. Let's kind of test it out. So the way we test it out is by going up. There's my equation. I'm going to plug this equation into the graphing calculator. So negative 2, negative 1, 2, and 5. So our function is negative 2 square root of negative 1 x minus 2? No, plus 2.
Negative x plus 2.
Yeah, well, I have plus 5. Great, you have it there. Okay, so here's our new function. Let's see if we've kind of put the correct points in. We had one coordinate. Scroll down here. Negative 2, 5. So let's put in our negative 2, 5. Exactly. That was when we had 0, 0. Now negative 2, 5. Negative 3, 3. Works out. That's where our 1, 1 had now changed to.
Yeah.
And then negative 6, 1. Negative 6, 1. There you go. Okay. So when you go to graph this, okay, you would just have these coordinates. As long as you understand that the root function is kind of curving that way, you would just kind of connect the dots to figure out the rest of that information.
So I should memorize that formula.
That little formula can be really helpful if you struggle with the general thing. And when you're doing that general thing in the mind, you really are running this formula through your head. It's just you just don't realize that you're doing it that way. Okay.